So one variation of a cosine graph shouldn't come to too much of a surprise to you. So imagine we have some y equals a times cosine bx. So what do you think the a and the b might represent? You're right, the a is the amplitude of a cosine graph as well, and the b helps us understand the period stretch, horizontal stretch, or horizontal shrink. And we determine that by taking the full period of the cosine graph, which is 2 pi, and divide it by the shrinkage factor, in this case, which is a b. And that will help us determine the period to determine where are our 5 key checkpoints at. All right, so let's look at an example. So I notice in this example, my amplitude is a -3. So my amplitude, or my value to help me determine that, is 3, -3 there. So I have absolute value of 3. So I drew my graph such that 3's are at the highest point because that's my amplitude. Now to find out the horizontal stretch or shrink, well, I'll have 2 pi divided by my b, which is pi halves. Work that out, and that flips flop, pi's cancel, equals a 4. So this graph runs an entire cycle from 0 to 4 over across 4 units. So how do I find each of the individual spots along the way? The zeros, the minimums, and the maximums? Well, I take that number and divide it by 4 to represent the 4 spots. So that tells me then that something happens at every 1 unit. So 0, 1, 2, 3, and 4. Those are my 5 key checkpoints for my x values. So let's find out what happens with the graph at each one of those values. So the cosine of pi halves times 0. So if I were to evaluate that one, just as an example, so -3 cosine pi halves evaluated at 0. Well, pi halves times 0 becomes 0. Cosine of 0 is 1. And then 1 times -3 produces my first value right there. Then when I put a 1 in there, what is my cosine of pi halves? Cosine of pi halves, if you remember correctly, is 0. At 2, the cosine of pi. And then I have my little fall into the rest of those points. So based on taking my 5 key points, 0, 1, 2, 3, and 4, evaluating them at this function, remembering what my values were at key points along the way, I was able to plot those 5 points. Step number next, which is to start to gently draw, as best as you can, a little bit of that sine or that cosine curve. Notice that in this particular one, it doesn't start at 0, but it starts along the x-axis. In this case, it starts at -3 because that is my amplitude. I have my 5 key points. A maximum occurs at 2, a minimum occurs at 0 and 4, crosses the x-axis at 1 and 3. So those are some things I want you to be aware of as you start to explore some of these variations with cosine graphs. I think we got one more to do. And another type of variation that we've discovered before with sines also deals with something called a phase shift, which means that our graph, once we have an idea what it looks like, we can shift it to the right or to the left, depending on what the ratio of C to B is. If C to B is positive, it's a shift to the right. If it's negative, the starting point or it begins with a shift to the left. So let's look at 1/2 cosine 4x plus pi and build the basic cosine graph and start to take care of all the shifting that we go on. Amplitude, 1/2. So my highest points are going to be 1/2 and -1/2, or my highest and lowest points of that particular graph. Cosine of 4x, that 4 helps me determine the period of the graph. So let's take 2b. This has 2 pi divided by 4, and that produces a pi over 4. So my full, yep. So the full period, something's just not looking right. Let me, oh, like I say, something wasn't looking right. Let me process that for a second. 2/4 is not 1/4. It's pi halves. All right, thank you for catching that. You guys know how sometimes when you're starting to work on a problem and your head does it right, but your fingers don't, and then you look like, what went on? All right, so back to our period. We know that this graph runs a full cycle only over a course of pi halves the amount of time. And now let's look at the phase shift. The phase shift is taking our value of pi, or our c, but notice though, it's written as 4x plus a value. It needs to be into a bx minus a c. So let's rewrite that then as y equals 1/2 cosine of 4x minus a minus pi. Those are the same, but now it's written as a negative or a subtraction. So that being the case, then my value of c is a negative pi divided by my b, which is a 4. And so my phase shift, or my starting point, is at negative pi fourths. So starting point, let's say this is my negative pi fourths then. There's my starting point. I know I have 4 more key points along the way in the cycle. How do I determine those? Well, the full period is going to be pi halves. So let's take pi halves. That's a full cycle. Let's divide that by 4 because there's 4 steps along the way. And that becomes then that every key point happens, looks like at pi eighths along the way. So my first point, x1, is negative pi fourths. My x2 is this point plus pi eighths more of the way around. Add those together, and so common denominator makes that a 2/8 negative. So it looks like a negative pi eighths is my next spot. So negative pi eighths. x3, or my third point, is I have a negative pi eighths. I know my next position is pi eighths past that. And that equals a 0. And then if I continue on with this, get the idea that my next point is going to be a positive pi eighths and then a positive pi fourths. So based on the information gathered so far, I was able to find the 5 key points. I know that there's a phase shift, so my graph is going to start right there. This particular period of the graph will start right there. From next, let's go ahead and take our values, insert that into the function, and get a value. So y equals 1/2 cosine of 4 times my x, which is a minus pi fourths, plus a pi. Um, 4 times minus pi fourths, fours cancel, negative pi minus a negative pi. I get the cosine of 0. Cosine of 0 is a 1. So my first value at the value negative pi fourths is a value of 1/2. Let's take the second value, which is a negative pi eighths, plug that in into the process. And I'll just do one more example for you just to show you that we can do it. So y equals 1/2 cosine of 4 times a negative pi eighths plus a pi. That becomes what, folks? 4/8 minus pi halves plus a pi. Add those together. Just lots of little small tedious steps. This becomes a 2/2 pi. Looks like we're left with pi halves. And the cosine of pi halves, if we remember, was a 0. So I have 1/2 times 0, which equals a 0. So my next point is right there. Then from there, plug in my rest of my points. And then draw a continuous smooth curve as best as you can. And there I went ahead and grafted the basic sine curve, or sorry, the basic cosine curve with an amplification of 1/2, which meant it was squished from the normal graph. The 4 helped define what the period was. And then I had a phase shift of, what is it, negative pi-4ths was my phase shift. So my graph starts there, so it was shifted back pi-4ths. You guys feel all right about that? It was kind of fun.